Hello class, today we're going to be going over section 3.2, the inverse trig functions. And so this first one that we're going to do, what we're going to do is we're going to attack the parentheses piece. And so just like in the previous section, I'm going to let theta equal tangent inverse of 1/2. And then that's going to yield tangent theta is 1/2. Now, one of the things that we need to remember is that tangent theta is equal to y over x. And so if we look at this in the coordinates, it would be x would be 2 and y would be 1. And so that would give us this point here. And if you look, that ends up forming a triangle. So this is 2, this is up 1, and then by using Pythagorean's theorem, 1 squared plus 2 squared is going to equal our radius squared. So we're going to get 4 plus 1 is equal to r squared, 5 is equal to r squared, and r, because it's a distance, is only going to be the positive case. And so now we know the radius. Sine theta, if you remember, is y over r. And so then sine theta is going to be the y piece, which is 1, over our r, which is radical 5. And that's going to, once we rationalize top and bottom, is going to be radical 5 over 5. So by using the inside information and using this triangle that we just developed, we know that this will be equal to radical 5 over 5. There's one example. Now let me do the next example for you. In the next example, again, we're going to let theta equal sine inverse of negative 1/3. And we know that there's a restriction there of a negative pi over 2 for theta to pi over 2. So it puts us in the first or fourth quadrant. And then sine theta is equal to a negative 1/3. So when we look at the values here, we know y is going to be a negative 1. Our radius is going to be 3. So this will be a negative 1. Now to get our x value, again, we can Pythagorize, and we're going to get negative 1 squared plus x squared, which we don't know, is equal to our radius squared, 3 squared. So we're going to get 1 plus x squared is equal to 9. X squared is equal to 8. And so x, again, it's a distance, and it's on it's on the positive side of the quadrant. So we're going to be 2 square root of 2. Now, again, we use the inside information. We'll use cosine of that inside information. So we're going to get cosine of theta. Cosine of the theta will represent the red piece because we're using that triangle. And so we know that cosine is x over r. And so cosine of theta is going to be the x, which is 2 radical 2, over the radius, which was 3. Now remember, the theta in the cosine is the red piece of our highlighted function. And so our answer is 2 radical 2 over 3. All right, the next example, we have tangent inverse. And so we're going to let theta equal cosine inverse of a negative 1/3. So cosine of theta is going to be equal to a negative 1/3. And the restriction there, again, remember, is from 0 to pi. So it puts us either in the first or third quadrant. So we're either in the first or third quadrant. But since our x is a negative 1 and our radius is 3, we're going to have to find our y. So negative 1 squared plus our y squared is equal to 3 squared, the radius. So 1 plus y squared is equal to 9. Y squared is equal to 8. So y is equal to 2 radical 2. And again, it's positive because it's above the x-axis. And so now that we have that, we know that tangent theta is equal to y over x. And so tangent theta is going to be our y, 2 radical 2 over our x, and our x was a -1. So that tells us that it's going to be a -2 radical 2. And so the answer to our problem is 2 radical 2. So the whole trick to these problems is finding substitutions for the inside piece by developing triangles. It's critical that for all of these, you have these memorized. That sine is going to be y over r, cosine is x over r, and tangent is y over x. Okay. Now, we need to remember there's some rules that we're going to have for secant, cosecant, and tangent. And so first with secant, it's secant inverse of x. And that means x is equal to secant of y, where the absolute value of x is greater than or equal to 1. And our y is going to be between 0 and pi. But y cannot be pi over 2. That's a restriction that we have. For cosecant inverse of x, that means that x is equal to cosecant of y, where the absolute value of x is greater than or equal to 1, and we're restricted from negative pi over 2 to pi over 2. So this one's going to put us in the first and fourth quadrant, while secant puts us in the first and second quadrant. Now, cotangent inverse of x means that we have x is equal to cotangent of y. And the restrictions here are it's from negative infinity for x to positive infinity. And our y is going to be from 0 to pi. So it also puts us in the first and second quadrants. All right, well, let's do an example with this information. And so with this problem, what we're going to do is we're going to let theta equal cosecant inverse of 2. So that tells us that cosecant theta is equal to 2. And so remember, the restriction for this guy is that we're going to be in the first or fourth quadrant, and that it can't be equal to 0. And so since this is positive, remember that cosecant is the reciprocal of sine. And so if we know where sine is 1/2, we can find out where cosecant is. So I know sine is going to be positive in the first quadrant, and sine of some angle has to equal 1/2. And so we know that sine is equal to 1/2 at pi over 6. And so we know that theta is pi over 6. So our answer to this problem is pi over 6. But remembering critically that cosecant theta is the same as 1 over sine theta. And so the reciprocal of sine is going to be cosecant, or the reciprocal of the sine value will give me the cosecant value too. And that happened at pi over 6. Okay. So our next problem that we're going to do is the secant inverse of 3. And so we know that if we let theta equal secant inverse of 3, theta will equal secant theta will equal 3. And then we need to remember that secant is the same as 1 over cosine theta, which is equal to 3. And so that would tell me that cosine theta would be equal to 1/3. And if we use a calculator to find cosine of that, we can do it by going cosine inverse of 1/3. And when we use a calculator, that yields 1.23. So the trick is to convert into cosine, get cosine to cosine inverse, and then from there get the value. Because we don't have on our calculators, unfortunately, secant inverse and cosecant inverse, so we have to convert those to cosine and sine respectively. So in our next example, we'll do the same thing. We're going to let theta equal cosecant inverse of -4. So cosecant theta is equal to -4. We know that's the same as 1 over sine theta would be equal to -4. And that sine theta then would be a -1/4. That would then become, theta would need to be sine inverse of a -1/4. And when we plug that into the calculator, we're going to get 0.25 negative. So again, the trick is going from secant to the inverse and cosecant to the inverse, and then solving those to become, in terms of inverses of the cosine and sine functions. Okay, one more example. Cotangent. So we'll let cotangent be, or we'll let theta be cotangent inverse of 2, -2. So then cotangent of theta is going to be equal to 2, and then let's remember the restriction here puts us between 0 and pi, so we're in the first or second quadrant. And so then if we remember, cotangent theta is equal to x over y. So this really is 2 over 1. And then from here, what ends up happening is we're going to get a graph that looks like a graph that gives us the point -2, 1. So this is -2, this value is 1. And then from here, what we can do is we can use the Pythagorean theorem, or 1 squared, and that's going to give us the radius. And so we're going to get 4 plus 1 is equal to r squared. That'll give us 5. And then since it's the radius, that's always a positive distance. That's going to give us the square root of 5. And so what we see from here is we know we're in that second quadrant, and we're going to be able to attack this problem by saying that cotangent inverse of -2 would be equal to our theta, which would be equal to cosine inverse of a -2 over radical 5, which is approximately 2.68. And the reason we used cosine here was it just happened to work out to be perfect for us to be able to use it in the second quadrant. All right, let's go on to the next example. And the next example, what we're going to do is we're going to work with the inside piece, and so we're going to let theta equal tangent of inverse of u, knowing that we have a restriction here. So then tangent of theta is equal to u, and we know that u has to be between positive and negative infinity. Since we have this here, what this ends up telling us is we're going to have to be in the first or the fourth quadrant. That's important. And since we know that, then we know that secant theta has to be greater than 0. And the reason secant theta is important here is because we know that tangent is sine over cosine, and we don't know if sine is going to be positive or negative because we don't know if we're in the first quadrant or the fourth, but we do know that cosine is going to be positive. And so if cosine is positive, then secant is positive because secant is 1 over cosine. Now, using that information, what we're going to do is we're going to go sine of tangent inverse of u is equal to sine of theta. And the reason we're calling it theta here, I wanted to address this, is we're saying theta is tangent inverse of u, just by substitution. So then from there, what I'm going to do is I'm going to go sine theta times cosine theta over cosine theta, which is the same as multiplying by 1, will give us tangent theta times cosine theta. And the way I got tangent was by, I'll use a different color. I went sine over cosine. Okay, now from here, I know that tangent theta is the same, tangent theta over secant theta is the same as tangent theta times cosine theta. It's just by multiplying by the reciprocal, because we know that secant in the denominator is the same as 1 over cosine in the denominator, which then we'll multiply and flip over. Now, from here, I know that tangent theta is equal to the square root, or tangent theta over 1 plus tangent squared theta. And one of the things that's cool here is this is the identity, and the identity is secant squared theta is equal to 1 plus tan squared theta. It's one of the identities I've already given you. So when I take the square root of both sides, I get my denominator. Okay, and what do we know that tangent theta is? We know, and I'll use a different color because I want you guys to be able to see this. We know that tangent theta is equal to u. So I'm going to substitute and call it u over 1 plus u squared under the square root. And this is what this problem is looking for. This is our solution. As always, I hope this is helpful. If you have any questions, feel free to email me or contact me. All the best.